Shahid, any problem in the word problems? We were discussing about the doubts. If you have any doubt, please feel free to ask. Because there must be a doubt. यार ये चैप्टर इतना इजी है नहीं. अभी तक हमने क्वेश्चंस बहुत मीडियम लेवल ही गए हैं. अगर हम थोड़ा टफर क्वेश्चन की तरफ मूव करेंगे तो देयर आर टफ क्वेश्चंस इन दिस चैप्टर. सो I believe if any one of you have solved questions from that portion, so you will be having doubts. You must have doubts, I mean, in that case. So feel free to ask your doubts. Because if this chapter is not clear application of derivatives and derivatives, then we will certainly face problems in integration. I mean, the first word I will speak in integration will be differentiation. Because integration and differentiation both are connected. If you know differentiation well, it would be easier for you to understand integration also. But if you don't know differentiation, very difficult to get integration. I mean, integration is top notch. Integration is the, toughest portion, I would say. Shahid, let me see. Integration is the toughest portion in your whole mathematics book. So now whatever the chapter that we are going to do will be the toughest. And this has a correlation with differentiation. If you are good in differentiation, then you may be able to get integration. I'm not saying you will, but you may be able to, or rather than you will be more equipped to handle integration. But if you have not practiced differentiation enough, then it will certainly get very difficult for you, all of you, to understand integration. Okay, 6.3, 27, 28, 29. Okay, just give me a minute. There is 6.3. I don't think it is in your. यार ये कौन सी एक्सरसाइज की बात कर रहे हैं? 6.3 में तो 26, 27 ही क्वेश्चन है, 28 तक गए नहीं. और आर यू आस्किंग अबाउट exercise 6.5? Yeah, cool. Because exercise 6.3 is already not in the syllabus. But if you want to ask any question from the portion which is not in the CBSE syllabus, please feel free to tell me. I'll take extra time. I'll take 15-10 minutes extra and I'll explain all the questions to you. Okay, 27, 28, 29. The point on the curve. Before that, also, you must have faced the problem in some questions like these. Cone wale questions will be very important. Okay, mark these questions here, please. From 18 to 26, all the questions are very important. Many of the questions have already been asked in the previous CBSE board exams. From 18 to 26, question number 18 to 26 in exercise 6.5 are very important. Okay, let's start with the doubts. I wanted everybody to join. If everybody would have joined, then we would have started integration easily. But now I know they will face problems if I start it today. Let's see. 27. Sorry, which was 27, 28, 29. Okay, cool. So first problem is 27, in which we are being asked to find the point on the curve. So the curve is x square is equals to 2y. We need to find a point on this point which is nearest, or rather we should write it like point on the curve, which is nearest to 0,5. Point on this curve x square is equals to 2y, which is nearest to this point 0,5, right? Okay, we also have options, correct. Okay. So let's first start with the information that we have. We know that there is a curve given, right? The curve is x square is equals to 2y, and we need to find a point. right? So we are looking actually. So consider your point. You can consider your point like this. Consider the point as, you can also consider the point as x1 y1, or you can consider the point as x comma y. Let's say the points are x comma y. We don't know about what is the value of x and what is the value of y, right? Or you can also say, I mean, you can also use this. So say that the point, consider the point as p comma q. Let's say the point is p comma q, right? If the point is p comma q and point lies on this curve, it means that we can replace x with p and y with q. If we do that, we get a relation between p and q. P square is equals to 2q. This can be further used in our investigation. Now, what do we want? Nearest. We want to find out, first information is that we have a curve on which a point is lying. We want to find out that point on this curve. The curve will have curve will actually have infinite points, right? A curve will have infinite points, right? But we want to find out that point, that particular point, which is nearest to this, which is nearest to 0, 5. Now, how do you find out which point is nearest? How do you, this is a question for you, all of you. I mean, I'm not asking for the methodology of this question. I'm asking a very simple question, general question. This has nothing to do with actually maths. It has something to do with maths, but it's not. It has nothing to do with differentiation right now. So I'm asking you a question. Let's say there are certain points. These are the points, and this is a point, right? And I'm asking you to find out the nearest point out of these points, which is nearest to this. So how would you find out that? What is the metric? How do you decide which point is the nearest? Anyone? The smallest distance, right? Distance. How would I decide? मेरे को पता तो ऐसे ही चलेगा ना कि यार ये इतने सारे पॉइंट्स दिए हुए हैं, मैं चाहता हूँ इस पॉइंट से सबसे पास कौन सा है, तो सबसे पास का तो मतलब ही है कि मैं चाहता हूँ डिस्टेंस निकालना, राइट? तो आई वांट टू मिनिमाइज द डिस्टेंस. Understand the problem first. I want to minimize the distance. Distance of what? Distance of p comma q from 0, 5, right? So nearest point or distance of nearest point. So distance of p comma q, right, from 0, 5, we can easily find that out, right? So this value would be root over. Tarif, please feel free to ask your questions. Right now we are taking doubts. We have been solving question number 27 from exercise 6.5. But if you have a doubt from any particular exercise or from any chapter, you can ask them. Right now we are on 6.5. Maximum and minimum. Okay, so we want to, so we can find out the distance of p comma q from 0, 5, which would be p minus 0 whole square plus q minus 5 whole square, right? And to the whole root. Let's say this distance is d, which would be root over p square plus q minus 5 whole square, right? So I can write this as a function of either p or q. Now, I don't know about p and q right now. I want to find out p and q, correct? So I need to differentiate the whole function either with respect to p or with respect to q. Right now, I have two variables, two unknowns. I will remove one using this relation first. I will put p square as 2q. So this becomes 2q plus q minus 5 whole square. Right? Now, I want to minimize this distance. This is my objective function. This is my objective function. And I want this to be minimized. Minimize the distance. How do we do that? We know that if we have a function and we want to find its optimum value, optimum means either minimum or maximum. Optimum is Optimum is used for either minimum or maximum. Extreme points. We want to find the extreme points of this, and extreme point maybe we want to find out the minimum value of this, right? How can I do that? I know that I have an expression which is in Q. So to find out the minimum or maximum value of this, I need to first differentiate this expression with respect to Q. So right now, what I am doing is I am basically differentiating this expression dq with respect to Q. I am differentiating this expression with respect to Q, which would be d dash Q. Now, what is this? First of all, root. So root ko we know that 1 by 2 root 2q plus q minus 5 whole square. I can also further solve this expression, right? Okay, let me solve it and simplify this. So this becomes q square plus 25 minus 10 okay, plus 2 minus 8. So this is nothing but this q square minus 8q plus 25. Let me erase this and rewrite this expression in its simplified form. So this becomes q square minus 8q plus 20. Right? Now, so first of all, root, then I will go to the inside expression, which would be 2q minus 8. Right? For minimum, put dq dash is equals to 0. So first of all, we will find out d dash q. Then we will put this d dash q. Now, d dash q is equals to 0. D dash q is 0. Then what is the value of key for which it happens? If a particular, we have already talked about this, if a particular fraction is equal to 0, then it is only 0 because of the numerator, right? Denominator cannot make a fraction equals to 0. So if this is 0, it means that its numerator is 0. It means that q is 4. Right? Now, next part. What can we do now? We should find out whether this is a point, whether this is actually a point of minima or not. How can we do that, Shahid? How should we approach? डबल डिफरेंशिएशन और फर्स्ट डेरिवेटिव से भी जा सकते हैं देखिए इस केस में तो, क्योंकि ये रूट वाली जो क्वांटिटी है ना ये ऑलवेज पॉजिटिव रहेगी. तो अगर फर्स्ट डेरिवेटिव से मेरे को जाना है तो देन आई विल हैव टू ओनली फोकस ऑन दिस, एंड यू कैन सी दैट इफ q इज ग्रेटर देन 4, इफ q इज ग्रेटर देन 4 देन दिस इज पॉजिटिव. चेक कर सकता है, q की वैल्यू 4 से बड़ी होगी तो ये पॉजिटिव होगा. इफ q ग्रेटर देन इक्वल टू 4, then this d dash q is greater than equal to 0, and if q is less than 4, then d dash q is less than 0. So जब q less than 4 है, this is decreasing, and when q is greater than equal to 4, then this is increasing. So first decreased, then increased will give you a point of local minimum. तो ऐसा नहीं है हमेशा ही सेकंड डेरिवेटिव टेस्ट लगाना, निकाल सकते हैं उसके बिना भी. बट हाँ, मतलब अगर बोला जाए स्पेसिफिकली कि यही करना है तो फिर तो वही करना होगा. if they have specifically told you that use either first derivative test, then you will have to use first derivative test. If they told you to use second derivative test, then you will have to use second derivative test. But if they have not mentioned any particular test, then you can use either of them and try to use which can minimize your calculation. So this is point of minima, right? So if q is 4, then you can find out what is p using the relation p square is equals to 2q. So if q is 4 and it is point of minima, then p square is equals to 2q, which implies that p square is equals to 8, which implies that p is 2 root 2. 2 root 2. I mean plus minus 2 root 2 obviously, but you will see that p 2 root 2 will be nearer as compared to p minus 2 root 2. Okay. I have a logic for this. So you are finding out the distance from 0, 5, right? 0, 5 would be somewhere here. Okay. And this x square is equals to 2y is somewhere. Oh, my bad. You can always use geometry, by the way. See, I'm also finding out the answer with geometry. How? This is x square is equals to 2y. This is a parabola. We know the shape of parabola. We have studied parabola in class 11. And this point, Shahid, we can observe this using the first derivative test, no? D dash q, the expression for D dash q is this. Now, in this expression, your denominator is always positive, correct? Because this is the answer of root. Square root never gives you a negative answer. Am I correct here? बस मेरे को बताता चल बीच बीच में, so that I know where do I need to repeat. Yeah, cool. So this quantity is always positive. Now I can certainly observe this quantity. If you take 2 common, then this is q minus 4, nothing but q minus 4. So there is only one linear factor, which is q minus 4, correct? If q is greater than 4, then this d dash q would be greater than equal to 0. And if q is less than 4, then d dash q is less than 0, which can tell us about dq. If d dash q is greater than equal to 0, then dq is increasing. If d dash q is less than 0, then this is decreasing, correct? Yeah, cool. So if we know about dq, then we also know. This is exactly first derivative test. First derivative test tells us कि अगर आपका फंक्शन डिक्रीज होकर इंक्रीज कर रहा है तो आप पॉइंट ऑफ लोकल मिनिमा से जाएंगे, और अगर आपका पॉइंट इंक्रीज होकर डिक्रीज कर रहा है मतलब आपका फंक्शन पहले इंक्रीज हुआ और फिर उसके बाद डिक्रीज हुआ, तो एक मैक्सिमम पॉइंट पे जाके अचीव करेगा ना वो, मतलब कहीं ना कहीं बीच में एक मैक्सिमम पॉइंट देके जा रहा होगा ना. ओके, लेट्स ट्राई दिस. अभी फंक्शन इंक्रीज हो रहा है, राइट? तो इंक्रीज हुआ 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 हुआ, फिर एक पॉइंट के बाद डिक्रीज होना शुरू हो गया, तो वो जो पॉइंट होगा जिसके बाद डिक्रीज होना शुरू हुआ वो हाईएस्ट पॉइंट होगा ना. ये देख, तो जब इंक्रीज होकर डिक्रीज करता है फंक्शन, जब इंक्रीज होकर डिक्रीज करता है तो तब पॉइंट ऑफ लोकल मैक्सिमा देके जाता है. जब डिक्रीज होकर इंक्रीज करता है तो पॉइंट ऑफ लोकल मिनिमा देके जाता है, करेक्ट? नाउ अंडरस्टैंड हियर, व्हेन q इज लेस देन 4, so plot it on a number line, minus infinity, plus infinity, and this is, let's say, 4. When q is less than 4, yani ki from this portion, in this portion, your dq is decreasing. And when q is from 4 to infinity, your dq is increasing. Your dq is increasing. तो अगर डिक्रीज करके इंक्रीज हुआ, इट विल गिव यू अ पॉइंट ऑफ मिनिमम, करेक्ट? अभी यहाँ पे एक बस मैं इतनी बात बोलना चाहूंगा कि हम वी कैन फाइंड आउट विच पॉइंट टू टेक. सी, द पॉइंट इज 0,5. the point from which we need to calculate the distance is 0,5. Now we want to know which point on this parabola is nearest to this point, correct? Now you got here 2 points. You observe these 2 points. First point is, it means that first point is 2 root 2 comma 4, and second point is minus 2 root 2 comma 4, correct? This is in first quadrant, this is in second quadrant. See, these points are this. Now as parabola is a parabola is a symmetric shape, as parabola is a symmetric shape, both of these points are nearest. They will have same distance from 0,5 actually. Hence the nearest points, so I can define this as x squared 2y is equals to 2y is a symmetric parabola we have two nearest and also the location of 0,5. Let's say if the point from which we were calculating the distance was here, then we will only get one point maybe. But क्योंकि ये बीच में है, it's contained within the parabola, that is why this distance as well as this distance both are same. we have two nearest points on it from 0, 5, right? And the points are did you understand this, Shay? Cool. And can we proceed to the next question, or are you writing it? If you are noting this down, then please tell me. Just raise your hand.
Can you explain that 22nd question?
Which question?
22nd.
22nd. Okay, we will move to 22nd also, but let me first complete 27 and 28 because Shahid has already asked those doubts, but we will certainly take 22 also. Okay, 28. So 28 says for all real values of x, the minimum value of 1 minus x plus x square upon 1 plus x square. Correct. Sure. We have many methods to solve this, by the way. But let me use the. Okay, so let's say this is the function fx, which is 1 minus x plus x square divided by 1 plus x square. Now we want to find out the minimum value. We want to find out the minimum value of this, correct? Okay. So first of all, we can write the same function. Also understand these transformations. I mean, these are good. If you love maths, if you are good in maths, then you should follow these transformations, which I am about to do here, which will basically reduce your calculations. How? So you can write this fx as, see, both of the expressions in numerator and denominator are quite similar. The only difference is it has minus x and it has plus x. So what I'm doing is I'm writing the numerator as this. I'm writing minus x as x minus 2x so that this expression becomes c. Now I'm writing it like this. What did I do here? I took this as a. I write a upon 1 plus x square minus 2x upon 1 plus x square. Now we know that a and 1 plus x square both are same. Are we clear here? If somebody is facing a problem, you can just raise your hand. Only just raise your hand. I would understand that I need to explain the concept again. So jahan pe bhi problem hoti hai, just raise your hand. Cool. So now, so first of all, this problem is Austin. We have just transformed our numerator in the form of denominator. So we have written minus x. This minus x has been written as x minus 2x. See, x minus 2x is also minus x. But why have I done that? Because this can reduce the expression in a simpler way. So before the expression was big, but now after this the expression is simpler than the first expression that we had. And in this case, I've just used 1 plus x square divided by 1 plus x square minus 2x upon 1 plus x square. This becomes 1. Is it okay?
Yes.
Okay. Now understand. We want to find out the minimum value of this. If you want to find out the minimum of this, now observe this. I want to find the minimum of whole of this. 1 is constant, right? What is this expression? I am subtracting something. I am subtracting something unknown. I'm subtracting something unknown from 1. And I want this value. I want this value to be minimum. Okay, let's take a case. Let's say this value is 0.5. Let's say this value is 0.5. If this whole value is 0.5, then this, I mean, this value 2x upon 1 plus x square is 0.5, then this whole value becomes 0.5, right? So I just want to show you something so that you can understand my concept better. So I'm writing the value of 2x upon 1 plus x square, and then I'm writing the value of whole expression. So if this is 0.1, then the whole expression becomes 0.9. Correct? Correct? If this is 0, then whole expression becomes 1. If this is -1, then whole expression becomes 2. Understand? As you are decreasing this, as the value of this 2x upon 1 plus x square is decreasing, the whole value is increasing, right? So if okay, now let's take this value as 1, the whole value becomes 0. Let's take this value as 2, the whole value becomes -1. Let's take this value as 3, then whole value becomes -2. So as you are increasing this gets decreased. So basically what I want to tell you is that if you want to minimize fx for minimum of fx, find maximum of this. If you want to minimize this fx, then maximize this. If you are subtracting 2x upon 1 plus x square from something, then जितना बड़ा subtract करोगे उतनी ही छोटी value मिलेगी, right? If I am subtracting a big number, then I will get a smaller number in return, right? So that is why we can also find out the maximum of this. So first of all, this problem that find out the minimum of this, and this problem that find out the maximum of this, both are same, similar, exactly same, identical. Both the question are same. Understand this thing. This is just for your knowledge part. We do know how to solve this. We could have solved it fairly easily through the same question. That is a very different point of view. But for your part, understanding part, I just want to tell you that there are transformations which can make your question simpler. So use these, try to use this transformation. They will help you a lot. Okay. Sure. So while finding out the maximum of 2x upon 1 plus x square, how can I do that? Okay. So either this or this. Sure. Now let's try to solve this. Let's say this is gx. Now we want to find out its maximum. So how do we do that? First, for maximum, put g dash x is equals to 0, right? So for that, first find out g dash x. What will be your g dash x? G dash x can be find out. So g dash x would be 1 plus x square whole square, and then denominator as it is, differentiation of numerator minus numerator as it is, differentiation of denominator, which would be what? 4x square. So this will be minus 2x square. Let me solve this quickly. So we will be putting this value equals to 0. This will give you two solutions. If you take minus 2 common, this will become x square minus 1. So hence g dash x is equals to 0 gives you x is equals to plus minus 1. Now we can go for second round. We can go for g double dash x to check. Also you can use your first derivative test only. So in first derivative, we don't need to use this part, denominator. Why? Because this is a square. This is always positive. This is an even power. Even power to mane, we can remove this from We can remove this from, okay, I'm taking -2 common. This becomes x square minus 1, which becomes x minus 1 into x plus 1. And this value is always positive. Hence, your whole expression, if you want to observe this expression, this only depends on your numerator, x minus 1 and x plus 1. Find out the roots, which are plus minus 1, plot them on a number line, and start with the sign which is outside the expression. Put that sign into the rightmost interval. We know how wavy curve works, right? So we know that g dash x is increasing, or sorry, g dash x is positive in -1 to 1, and g dash x is negative in -infinity to -1 and 1 to infinity, right? Which says that gx is decreasing in -infinity to 1, gx is increasing in -1 to 1, and gx is decreasing again in 1 to infinity. So this point, negative, first decrease, then increase. So it is a point of local minima. And then this is a point of local maximum. Right? Is it clear? The question is clear to you or not? Okay. Shahid, sorry. One, what do we need to find out? I guess yes. If we needed to find out the local maximum, then yes, for this function, one, and subsequently one will give you the minimum value for the actual function where we have started. And but we need to find out the minimum value, not the point of local maxima or point of local minima. So 1, x is equals to 1 is a point of local minima for fx. Now come to your original function fx. So find out the minimum value f1, which is 1 minus 1 plus 1 square divided by 1 plus 1 plus 1 square, which is nothing but 1 by 3. So your answer must be 1 by 3, I guess, not 1. And then 28th also, that is same, Shahid. I mean, as you have solved 28, 29th will be same. I mean, the power is 1 by 3, but we can differentiate the whole expression, put it equal to 0, and then apply either double differentiation also. I mean, first derivative or second derivative. You can solve this easily. Try this out. If this don't work out, doesn't work out, then please tell me. Which question, Tari? Which were you asking? Question number 22.
Yes.
Sure. Let's start with 22. A wire of length 28 meter is to be cut into two pieces. Okay. Let's say this is the wire. The length is 28 meter. And it needs to be cut in 3 equal pieces. Okay. It needs to be cut into 2 pieces. Okay. Let's say these are the 2 pieces, AC and B. Let's say this length is X, then this would be 28 minus X. Correct? My bad. Sorry, I had a call. Yeah, so a wire of length 28 meter is to be cut into 2 pieces. One of the pieces is to be made into a square and the other into a circle. Cool. What should be the length of the 2 pieces so that the combined area of the square and the circle is minimum? Okay, cool. So let's say this is one part is AC and one part is CB, correct? And one part is of length X. So let's use these 2 parts. Let's say I'm using this AC to form a square and I'm using this CB to form a circle. Right? This is a square and this is a circle. एक वायर था 28 मीटर लेंथ है इसकी, राइट? इसको 2 पार्ट्स में कट करना है. One part will be used to make a square and other part is used to make a circle. It means that the perimeter of the square is equal to X. Okay, we have to solve this. So we need to emphasize on the information that we have here. So one information is that we have a wire which is of length 28 meter and it is being cut into 2 pieces. This is an information which actually tells us if there is one wire, I mean, if one piece has a length of X, then another piece will have 28 minus X meters length. Correct? This was used for this information. Now, the next very important piece of information is that this X is the perimeter of square. Because you have used this whole X to make the square. Right? So if perimeter of square is X, can we know the side of square? Can you tell me side of square? What will be side of square? Anyone? Is it that term? X by 4, correct? Yeah. So if your perimeter of square is X, then side of the square is X by 4 meter, correct? Now, we again know that the perimeter of circle is 28 minus X. Can you tell me what will be the radius of this circle? I mean, for a circle, I need to know the radius. For a square, I need to know the side. We know what do we need to know to define a circle or to define a square. To define a circle, I need to know just its radius. If I know the radius and I know the center, I'm good to go with the circle. But right now, I don't need circle. I just need its radius. So how to find out its radius? Anyone? Are very good. Chavez, Austin, both of you are correct. Good. So this perimeter of the circle is 28 minus x. Now, what is the perimeter of a circle? Circumference, which is 2 pi r, which is 2 pi r. So 2 pi r is equals to 28 minus x. It means that your length of radius is nothing but 28 minus x upon 2 pi. So these are two pieces of information which will be very crucial for us. Why? You will know very soon. Why? Okay, now what is objective function? We need to minimize the sum of area of this square and circle. Just a minute. Let me read that again. What should be the length of the two pieces? Correct. It means that they have asked us to find out x. What would be x so that the combined area of the square and circle is minimum? Okay, combined area. What do we want to do? Combined area of square plus circle should be minimum. This is our objective function. So first of all, find out the area of square. Can you tell me, anyone? Please open your mic. Don't write on the chat. Just open your mic and answer me fatafat. What should be the area of square? Alright. It's not a question. Area of square. Shayad you are not audible if you are speaking something. Chavez, what would be area of square? Correct, Shahid. Side square. And what would be area of circle, Tharif? How do we find out area of circle? Any circle?
Area of circle pi r square.
Pi r square, correct? So we want this combined to be minimum, right? Okay, let's write the combined area first of all. So combined area would be side square, area of square plus area of circle. Area of square would be x by 4 whole square, because the side of the square we know that it is x by 4, plus pi into r square. R square would be 28 minus x upon 2 pi whole square. We need to minimize this function. We can write this function as ax, that is, this is area with which is given in x. Now we can easily, it's okay, Sharon. We can easily find out the minimum and maximum value of it. Just solve this. This will be something along the line of 28 minus x whole square. This will be 4, 5. So basically you have to minimize this. We do know how to minimize, right? Chalo, let's try. So for minimum, put a dash x is equals to 0. Right now we don't have a dash x. So let's find out a dash x. This would be 2x upon 16 plus 2 times 28 minus x into minus 1. Chain rule. Power first. पावर का होगा 2 नीचे आएगा, एक पावर घटेगी, फिर अंदर जाएंगे 28 माइनस एक्स, 28 का 0 माइनस एक्स का -1. We need to put this equal to 0. This will give us a value of some value of, x. We will solve that value. We will find out this -1 जब उधर जाएंगे तो प्लस हो जाएगा. Don't worry about the calculation part. You can solve this later on. So this will be something. To find out whether its point of local minima or local maxima. Let's again find out a double dash x. To check, find a double dash x. So your a double dash x would be x by 8 would be 1 by 8 minus this would be upon 2 pi, and 28 minus x would be minus 1 again. So you can see that a double dash x in itself is a positive quantity, which means that this is what? That this is a double dash x is, if a double dash x is greater than 0, it means that whatever you get, this is the point of local minima. It does not depend on x even. तो जो भी पॉइंट मिला हमें पिछले वाले स्टेप पे, वो तो सीधा सीधा पॉइंट ऑफ लोकल मिनिमा है, क्योंकि ए डबल डैश एक्स की वैल्यू हमेशा पॉजिटिव है. ये पॉइंट हम रखेंगे. सो वी शुड डिवाइड 28 मीटर इनटू वन पार्ट ऑफ 112/4 plus 5 and another part would be 28 minus this value. तारीफ समझ आई ये बात?
Yes, sir.
It was square in the denominator actually. 2 pi whole square would be 4 pi square. 1 pi cancelled out 1 pi. See here. This was square. So in the denominator, we only have 1 pi. ठीक है यार, अच्छा लगा मेरे को. I felt good that you have asked 3-4 questions at least, and I believe that you have not just asked them, you have solved them. So okay, we will start with integration in tomorrow's class, and I think you have been misinformed today about the class timing. So they have, I mean, obviously they have not done it intentionally, but unintentionally they have mistakenly sent you the message from 5:30. But tomorrow we will have the class from 5 to 6:30 only. Okay, so we will start with integration, and please everyone please be present. Don't miss even a single class in integration, guys. It will be really tough for you. I mean, it is tough for me also. I know how problematic it can be to explain this topic to the students, particularly to the students who are not so much involved in mathematics. So, and this chapter will include like 12 to 13 marks in your board exams. Only this single chapter. Then we will have 2 more chapters based on the same chapter, integration. So now we are entering into integral calculus. For the next 1 month, you will intensively be solving integration only. I will try to explain each and every question as well as steps but it is extensive, it is intensive, so you can't take this lightly. मतलब सबसे टफ चैप्टर होने वाला है. मैं तुम्हें हिंदी में बता दूं ना अगर ये बात बहुत तमीज से, तो ये ना तोते उड़ा देगा तुम्हारे सबके. इंटीग्रेशन इज नॉट इजी गाइस. मैं तुम्हें तब का भी बता रहा हूँ जब मैं तुम्हारी एज में था. और मेरे को बहुत ज्यादा इंटरेस्ट था भाई मैथ्स में, बहुत ही ज्यादा. आज भी है, तब भी था. मेरे को बहुत पसंद था मैथ्स, बट ये चैप्टर से मैं डरता था, मैं भागता था इससे. तो ये चैप्टर ऐसा होगा, नेक्स्ट चैप्टर के बिल्कुल इजी नहीं होगा. आई नो इट विल बी टफ, बट I can assure you that I will be with you guys. I will explain every step. I will not irritate. I will not get irritated. I'll not stop until you don't stop. Okay. So please try to attempt all the chapter with me. और कोई क्लास मत छोड़ना. Don't miss a class. Don't miss the assignments. Don't miss the exercises. If you are with me throughout every exercise, however time it takes, कितना भी टाइम लगे, कोई फर्क नहीं पड़ता. I'll complete the chapter with your pace, guys. I know how important it is, so that is why I'm saying this. I will complete the chapter with your pace, not with my pace. But for that, I need a promise that you will be with me. If you are not able to solve a particular exercise when I gave you that in the homework, don't worry. We will take that exercise in the class. We will solve the exercise, full exercise. If you are not able to solve even a single question, I'll solve full exercise. Don't worry about that. But please be with me. If I give you some homework, please solve that out. If I tell you to read something, please read that, and please work hard on this chapter. एक ही चैप्टर की बात है, एक बार करके देखो, देखते हैं कैसा होगा. This is just for one chapter. I want everybody to put whatever efforts you can put in this